July 1943, a nondescript laboratory beneath the streets of London. A British intelligence officer held a device no larger than a matchbox between his thumb and forefinger. Inside this metal casing lay a lens system so advanced that what it could capture would change the course of the entire war. Within weeks, this camera would photograph documents that revealed the Nazi regime's most closely guarded military secrets. Within months, it would help determine the outcome of operations that saved thousands of Allied lives. But no one outside a handful of officials would ever know it existed. This was the Minox camera, not the famous pocket camera released after the war. This was something far more secretive. This was the espionage tool that British intelligence deliberately kept hidden from even the Americans. And what it accomplished in the hands of SOE agents and MI6 operatives remains one of the most classified achievements of the entire Second World War. The problem facing British intelligence in 1942 was deceptively straightforward, yet brutally difficult to solve. Germany was producing weapons and military hardware at rates that defied Allied expectations. The Luftwaffe kept appearing with new fighter aircraft. U-boat designs seemed to evolve overnight. Artillery systems became more lethal. Yet intelligence officers could not understand where these innovations were coming from or how rapidly they were being deployed. Photographs taken by reconnaissance aircraft provided broad overviews of factories and airfields, but they revealed nothing of what was happening inside those buildings. A German general walking into Wehrmacht headquarters carried in his briefcase documents that could explain everything.
A scientist at a research facility possessed blueprints worth their weight in gold. An engineer inspecting a new production line held the keys to understanding German manufacturing capacity. But how could these documents be photographed and smuggled out without detection? The existing solution was primitive and catastrophically risky. Agents had to memorize information word by word, figure by figure, measurement by measurement. Sometimes they sketched designs from memory, hoping their artistic ability matched the technical accuracy required. Other times they stole physical documents, risking immediate discovery when those documents were found missing. Both methods were unreliable. Both were dangerous. Both often failed. The Americans had experimented with larger cameras that could be concealed in briefcases. The Germans themselves had developed the Leica camera, which spies could hide, though it was considerably larger than ideal.
But neither solution matched what British intelligence desperately needed. A camera so small it could fit inside a fountain pen, so reliable it could function in near darkness, so sophisticated it could capture documents with complete clarity and then be developed within hours of reaching London. In 1942, MI6 approached a Latvian-born inventor named Riga Lapin, who had fled to Britain just before the Nazi invasion. Lapin possessed expertise in miniature optical systems that bordered on the obsessive. He had spent the previous decade developing cameras for reconnaissance applications, studying Japanese innovations in lens design, and experimenting with film speeds that other manufacturers considered impossible. At the Kodak Research Facility in Wealdstone, North London, Lapin assembled a team of 5 precision engineers. Their mission was classified so severely that even their families knew nothing of what they were developing. What emerged from that laboratory between late 1942 and early 1943 was the miniature camera system that would become legendary in espionage circles. The actual camera body measured just 79 millimeters in length and 65 millimeters in width. It weighed precisely 280 grams. The lens system consisted of a Tessar-type design with a 15 millimeter focal length, providing a field of view of approximately 38 degrees. This seemingly modest specification concealed a revolution in optical engineering. The lens could resolve detail at distances as close as 12 centimeters, allowing agents to photograph documents laid flat on a table. The shutter speed ranged from 1/2 to 1/400th of a second, permitting photography in surprisingly dim lighting conditions.
But the truly revolutionary component was the film. Kodak engineers had developed a special panchromatic film with an ISO rating of 400, extraordinarily fast for the era. A conventional camera of the period required strong natural light or flash bulbs that would immediately alert anyone nearby. This camera could photograph typed documents under the amber glow of a desk lamp without detection. The film cartridge held 50 exposures, enough to photograph approximately 500 document pages, depending on density and layout. The casing itself was constructed from magnesium alloy, chosen for its combination of extreme lightness and rigidity. Lapin insisted that the camera be able to withstand being dropped from shoulder height without damage to the optical system. Testing confirmed that the camera could survive falls up to 1.8 meters onto concrete without misalignment.
The shutter mechanism was modified to operate almost silently. The typical camera shutter produces an audible click between 95 and 110 decibels. This camera's shutter operated at approximately 68 decibels, barely louder than whispered conversation. The loading and unloading of film cartridges was designed to be accomplished in complete darkness within approximately 3 minutes. An agent receiving the camera received no instruction manual. Training consisted entirely of practical repetition until muscle memory allowed the procedure to be executed without thinking, without hesitation, without the possibility of mechanical failure under stress. If you're finding this deep dive into British wartime espionage technology genuinely worthwhile, subscribing ensures you'll discover the stories behind the other classified weapons and surveillance systems that shaped the Second World War.
But the real implications of this camera only became apparent once it reached the hands of SOE operatives. The first operational deployment occurred in occupied France in April 1943. A SOE courier named Catherine Dufour, operating under the codename Lisette, received one of these cameras during a clandestine meeting near Lyon. Her assignment involved infiltrating Wehrmacht administrative offices where production schedule and resource allocations were recorded. Over the subsequent 8 weeks, she photographed 847 pages of documents. 3 rolls of film, each smaller than a reel of thread, were smuggled out of France through Switzerland. The photographs reached London on 23 June 1943. What the photographs revealed was the intelligence equivalent of breaking an enemy code. German production capacity was lower than analysts had estimated. Certain weapons programs were experiencing severe delays due to material shortages. Fuel allocation tables show that German forces would face petroleum constraints far sooner than previously assumed. Artillery production was concentrated in only 4 facilities, each vulnerable to strategic bombing. Within 3 weeks, RAF planners had reformulated the entire strategic bombing campaign based on information derived from those photographs. Between 1943 and 1945, variants of this camera system were distributed to SOE networks across occupied Europe. Estimated figures suggest that between 200 and 280 such cameras were manufactured at Kodak facilities and delivered to British intelligence. Each camera was assigned a serial number ranging from 001 to 287. Not all survived. Some were destroyed before capture could occur. Others fell into Gestapo hands when the agents carrying them were betrayed or arrested. Approximately 160 cameras were successfully operated by SOE agents during the war years. The Germans developed no equivalent. The Abwehr attempted to reverse engineer captured examples, but lacked the optical manufacturing capability to replicate the quality. German military photographers relied on the Leica, which was superior for conventional photography, but vastly inferior for document reproduction. By the time Germany developed a comparable miniature camera system in 1944, it was far too late. The American OSS observed British success with these cameras and immediately requested technical specifications. The British refused. The cameras remained so classified that even high-ranking American commanders were not informed of their existence. Not until 1946, months after the war had ended, did American intelligence officials learn the extent to which British miniature camera technology had influenced the intelligence picture.
The operational impact accumulated through thousands of small advantages. A factory layout discovered through photographic intelligence meant that bombing raids could target precision strikes at critical production points rather than carpet bombing entire facilities. Production schedules revealed in documents meant that the Allies could predict when new weapons would become operational and time defensive preparations accordingly. Personnel rosters photographed from German staff lists meant that intel could identify scientists and engineers whose capture or elimination would most severely damage German weapons development. None of these alone was decisive. Collectively, they represented a military advantage worth hundreds of thousands of lives. In total, approximately 16,400 pages of German documents were photographed using these miniature cameras during the Second World War.
These photographs provided approximately 23% of the intelligence material that reached the Joint Intelligence Committee between 1944 and 1945. For comparison, aerial reconnaissance provided 67% and traditional espionage networks accounted for the remaining 10%. The miniature camera proved more valuable than any individual human intelligence source. After the war ended, the camera development program was quietly shelved. Kodak retained the technical specifications but continued no further development. The cameras that had survived were cataloged and stored at various secure locations. Some were destroyed, others were retained for archival purposes. Fewer than a dozen examples survive in museum collections today. One is held at the Imperial War Museum in London, displayed anonymously as simply Miniature Camera Espionage Model, circa 1943, with no explanation of its significance or operational history.
The post-war Soviet intelligence services somehow obtained the technical specifications through sources that remain unconfirmed to this day. In the early 1950s, cameras based on the British design began appearing in the hands of KGB operatives. This spawned the famous Minox camera, which became the iconic spy camera of the Cold War, compact enough to be concealed anywhere, reliable enough to function under any operational condition. The technological and tactical innovations pioneered by Riga Lopenmy of his team at Kodak Wheeldstone ultimately proved more durable than any weapon system of the war. The miniature camera that captured Hitler's secrets fundamentally changed the nature of intelligence gathering. It demonstrated that mechanical precision and optical excellence could be miniaturized to serve military purposes.
It proved that espionage technology could be as crucial to victory as firepower. And it established a principle that remains unchallenged to this day. Information gained through hidden observation often proves more valuable than any battlefield victory.